Graphs of rational functions. Find the domain of the function f. Use limits to describe the behavior of f at the values of x not in its domain. So, number 2, f of x is equal to negative 3 over x minus 1. So how would I find the values that are not in its domain? Because this should be review.
You have to solve for x first, right?
Set the bottom to 0.
Set the bottom equal to 0, so x minus 1 equals 0, so x equals 1. So my domain is negative infinity to 1, union 1 to infinity.
Was there ever a time we use brackets for these ones?
Yes, if it's including a value. This is not.
Okay.
Now it says to use limits to describe the behavior of f at x not in its domain. So what we're going to do is we're going to take the limit as x approaches 1 from the left. So if I put a little negative sign up here, like where we would normally have an exponent, that means from the left of f of x. I'm seeing what happens. So 1 from the left would be like 0.99999. Okay? So if I put something like that in there, I have negative 3 over a really small number. What happens? A really small negative number. What happens?
It's positive.
Positive what?
1.
Nope.
Or 3.
Nope. All right, take out your calculators and plug in for x, plug in 0.99999.
Oh, you're graphing that?
No. Just plug in the number. Negative 3 over 0.99999 minus 1.
You're like 1.11111. I think. I don't know my calculator's not working. So negative 3. Nope. Negative 3 divided.
Oh.
Minus 1. Negative 4.
300,000.
So
AKA a really big number. So
Watch.
positive infinity.
Okay.
So we had negative 3 divided by 0.9999999.
Minus 1. So basically on the bottom it's negative 0.0000001.
So negative 3 divided by 0.9999999.
Minus 1.
Negative 4.
Oh,
I see what I did. Quite didn't.
All right, now I need to do the same thing but from the right. So the limit as x approaches 1 from the right, we put a little plus sign there of f of x. So if I had negative 3 over 1.0000001 minus 1, what would I get?
Negative infinity.
Negative infinity.
What y'all are doing different.
So that's essentially proving to us that there's an asymptote there, that there's a problem because it's going to infinity or negative infinity. So we just confirmed that we did it correctly to find our domain. Number 4. F of x is equal to 2 over x squared minus 1. So I want to find the domain of this function. So what do I do first?
Set it equal to bottom equal to 0.
So I have x squared minus 1 equals 0.
Equals 1. But x equals plus or minus 1.
Yep. So that means I'm going to have 4 limits to check on this one. So the domain of this function would be negative infinity to negative 1, union, negative 1 to 1, union 1 to infinity. We're not including any of those because those numbers would cause a problem in there. So I'm taking the limit as x approaches negative 1 from the left. So you have to think about these numbers logistically. That would be like negative 1.00001, okay, when you plug it in up there.
So we're putting in our calculator 2 over 0.1111111.
No, negative 1.00001. Because I need a number to the left of negative 1. That's just
Okay,
barely
but
to
only
the
a
left of
little
it.
bit.
Yeah.
Okay, so 2 divided by
So basically do a negative 1 point, a bunch of zeros, and then a 1.
negative. I got negative 2. Okay, 2.
Did you remember to square the number?
Oh yeah, forgot about that.
Wait, you said to put what as x?
Like negative 1.0000001.
1.9999996.
Is that like times 10 to the something there?
It's only the 1 point blah 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 being
It's
squared,
like
right?
negative 0.99.
2. Division
So
simple.
mine was negative
Parentheses symbol.
0.99999 something 5.
Mine was positive. 999.
I'm not sure we're all putting these in the calculator in the same format.
Well, I used parentheses for it, so.
I did too. But we might have put our parentheses in different places.
I believe it should be positive infinity. Because if you're placing in the negative under the negative, it being squared.
So I got almost a million with what I just put in there.
How'd you get a
so I got-
matrix?
Would mean it. I didn't do anything with the matrix.
okay,
It
so we
was already
have-
in my calculator.
Second math. Nope. Wait, no.
So yeah, that's
Alpha
Alpha
y
y
equals
equals-
gives you a fraction bar.
Okay,
I would wager some of you that are not getting the right answer are probably putting the negative sign outside of the square, so it's not squaring it.
Oh, it's
Oh,
negative
that
1
makes
point
sense.
zero, zero, zero,
Makes sense, yeah.
1. Parentheses.
Does it really matter how many zeros?
Squared.
Just I would do at least like 4 because that way you see the really big number. 'Cause
I got
otherwise,
1
you're not
euro.
necessarily gonna see it. Huh?
1E11. What did you just say?
So that means it's a big
111.
number.
That means it's a really big number.
What does E mean?
Times 10 to the whatever power. Scientific notation. But the
Oh,
E is the calculator version of that. Alright, now we gotta do the limit as x approaches negative 1 from the right. So that means I need negative 0.999999 going in there.
Alpha y equals 92 divided by parentheses negative 0.9. Wait, not 0.10001.
No.
Oh, because you gotta go to the right. It's 0.01.
Negative infinity.
Syntax.
And we're just picking those numbers to put in there, right?
Yeah.
Like, okay.
Now, eventually you should get to where you can visually see what's going to happen without even having to type them in. Like most of them I can just look at and know exactly what's going to happen. But until that point, I would say just use your calculator to plug in numbers. Now, we've so far accounted for negative 1. I now need to do the same thing for positive 1.
Won't it just be the same?
No, it'd be flipped.
So the limit as x approaches 1 from the left, so that would be positive 0.99999.
It's gonna be
negative 1e11.
Yeah, so negative infinity.
And then the limit as x approaches 1 from the right, 1.00001.
Positive infinity.
And that makes sense because the numbers were being squared and these are swapped. So big things here is if it tells you to find the domain, obviously you have to do that, but you also have to confirm it with limits. So if like on the test or the quiz you have a question that says find the domain and confirm with limits and you don't, you're losing a lot of credit because you didn't complete what the instruction said to do. Okay. The next problems say to, they have a whole lot of instructions here, but it says identify the horizontal and vertical asymptotes and use limits to describe the behavior. So we're not doing all of the instructions, so I'm going to write for 5 through 10, find vertical asymptotes and horizontal asymptotes, confirm with limits.
And what's different from that, from what the book says?
Describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function g of x equals 1 over x. Identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior. Sketch the graph of the function.
I thought you said all the instructions. I was like,
No, I only read the parts that I cared about. Yes. All right, so number 8. F of x is equal to 3x minus 2 over x minus 1. All right, how do I find the vertical asymptotes?
X equals 1.
So we would do x minus 1 equals 0, so x equals 1. So yes, my vertical asymptote is x equals 1. Remember, if you don't write it as an equation of a line, you will not get full credit. Horizontal asymptote, how would I find the horizontal asymptote?
Y equals b, so we have to do
Oh, is this where we use Bosco, Botno, and Bobo?
And the powers
Oh.
are the same.
it's
So
3.
it's 3.
Yep, they're both the same, so we use the coefficient, so y equals 3.
Can we do that? What?
It's Bosco.
So what is it?
Both of these have the same power, so we use the coefficients in front. So this would be 3 over 1, which is just 3.
If they had different.
If it was like, if this was a 2 here, then it would be 3 over 2.
What if it was 3x over x squared?
Then that would be bigger on
2.
bottom, so y equals 0.
But yeah.
So if it's always bigger on the bottom, it's always going to be 0?
Yeah. Bobo is bigger on bottom, y equals 0.
Okay.
Botno is bigger on top. No, there's not, so there's none. In which case we'd have a slant asymptote most times, not all the time. And then Bosco, if they're both the same, we use the coefficient.
That's smart. Why didn't I learn this before?
You did, like, 3 weeks ago.
No, I didn't learn it. It's just, I wasn't paying attention.
I was like, okay. All right, so now we have to confirm with limits. So the way that we confirm a vertical asymptote is by looking at the limit as x approaches that from the left and the right. So the same way that we just found domain. So domain and vertical asymptotes pretty much are found the same way, with the exception of obviously if we didn't have a rational function. But this whole section is rational function, so we do it the same way. So the limit as x approaches 1 from the left of f of x would be equal to what?
Okay, so we're putting
So we
in
would want to plug in like 1, well,
0.9999 for x.
so from the right is a whole number and from the left is a fraction or a decimal.
From the No, they're both decimals.
So it's negative
But I
infinity.
thought last time it was 1 point something 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 from the right to the left. What from the left was 0.9999.
But that depends, because if the thing was at 2, then it would be 1.99999.
Okay.
Like they're always decimal
so
numbers.
It's like as close as you can get to the number without actually touching it. Okay.
My calculator was rounding. I got negative a
It's
lot of
rounding?
nines.
Yeah, it's like I put in a bunch of nines and it just rounds it to 1.
I don't know because you have a calculator that's not the one on this pie list, so I'm not sure.
I got negative a lot of nines. So a really big negative number.
Okay, so this would be negative infinity. And then the limit as x approaches 1 from the right, so 1.0001,
Infinity.
positive infinity. If these are opposite, then you've confirmed that that's your vertical asymptote. One has to go to positive infinity, one has to go to negative infinity.
What if there's no HA? Or horizontal asymptote?
Then you don't do anything for the limit. We've only done vertical right now.
Okay.
This is the vertical one.
What is
The horizontal one, what?
what is a rational function?
A fraction. Function that's in fraction form.
That's
All right, for the horizontal one, we look at the limit as x approaches negative infinity of f of x. It should be equal to the limit as x approaches positive infinity of f of x. And we're going to find what that number is. So if I plug in negative infinity, then all I care about is the numbers in front. Okay, I don't care about everything else. I care about the highest powered terms only. So if I plugged in 3 times 500 over 500, what do I get?
500. Wait.
3 times 500.
AKA cancel the x's. What do I get?
3.
3.
I was right.
Now, do it at negative 500. 3 times negative 500 over negative 500. What do I get?
3.
3. What was my horizontal asymptote?
3. Wow. That's amazing.
And if it was bigger on bottom, then it would just be something over a really big number. And so then it would be 0 for checking the limit. Another one of these, 10. F of x equals 4 minus 3x over x minus 5. So I would probably recommend before you do anything else that we rewrite this as negative 3x plus 4 over x minus 5, because on that last quiz, y'all proved to me that you don't always pay attention to the order that things are written in. So I would rewrite it so that you don't end up getting the wrong horizontal asymptote. It won't make a difference for vertical, but. So what would the vertical asymptote be on this one?
X equals 5.
Yep, x equals 5. What about horizontal?
Negative 3. Because they're the same.
Yep, y equals negative 3. All right, so confirm with limits. So we've got the limit as x approaches 5 from the left of f of x. So this would be like 4.99999.
negative.
Are you sure?
Oh, because it's not negative on the top, so it's positive.
And then the limit as x approaches 5 from the right.
The heck do you mean error?
Negative infinity.
Negative infinity.
So what number did you plug in for from the right?
5.00001.
Error again.
Are you putting the number in parentheses? parentheses or not?
Yes. Oh, I see what I did wrong.
All right, next, the limit as x approaches infinity of f of x is equal to the limit as x approaches negative infinity of f of x. So what happens when I plug in infinity for x?
It's
Or a big number like 500.
-3.
What happens when I plug in negative 500?
You get a fraction.
3.
Negative 3. So this is equal to negative 3.
Nice. Does it get harder?
I mean,
I don't want to say anything about how good I'm doing on it if it gets harder.
depends on if you can read and follow all the instructions. It's not really harder, just following a lot of instructions. All right, 20. The same instructions for what we've been doing, but f of x is equal to 3x squared over x squared plus 1.
We're gonna have 4 limits, 8 limits total. Right?
No, you were right with 4.
All right, so how do I find my vertical asymptote?
It's equal to 0, so it's x equals.
So x squared equals negative 1.
So x equals.
Square root of that
is I1.
plus or minus I, which means there's not a vertical asymptote.
So it's not a.
So there are no vertical asymptote limits.
Sure. Oh,
Now, what's my horizontal asymptote? 3. I've got x squared and x squared, so it's just a number in front. And then the limit for that one, limit as x approaches infinity of f of x is equal to the limit as x approaches negative infinity of f of x, which is equal to what? 3. All right, I'm going to do 22. We're going to say what the vertical asymptote is, but I'm not going to find the limits just for the sake of time because we have another problem we need to get through. But I want to look at the horizontal asymptote on this one because this one's different. All the other ones have been the same. F of x is equal to x minus 3 over x squared plus 3x. So I need to find my vertical asymptotes.
So, set it equal to 0. Divided by 3.
Can't do that.
Oh, square root each side.
Take out an x.
Can't do that. Take out an x.
I hate this game. Divide each side by x.
Can't do that.
Oh, set x equals 0 and x plus 3 equals 0.
Oh.
So x equals 0 and negative 3.
Yep, so x equals 0, x equals negative 3. Both of those are vertical asymptotes. You would need to do the limits of these. But I'm not going to for the sake of time because we've already done several of those. I just want us to talk about the horizontal asymptotes on these ones. So this one is,
Bobo.
so what's the horizontal asymptote?
Y equals 0.
Y equals 0. So the limit on this one, I just want us to see this. When I do the limit, all I need to look at is this piece right here. So the limit as x approaches infinity is equal to the limit as x approaches negative infinity is equal to what? So if I put 500 over 500 squared, then I would get 1 over 500. And what happens?
That means it's getting closer to negative infinity. We're getting closer to 0.
Getting closer to 0. Now if I plug in negative 500,
It's the same. Yeah.
it's just getting really close to 0 essentially from the other direction. So both of these are 0. So I just wanted us to see one with the limits that was not just the number straight up.
What is your comprehension?
All right, the last problems you're not using limits for, but you still are finding the asymptotes and the intercepts of the function. So 24, g of x is equal to x plus 2 over x squared plus 2x minus 3. So the first thing I need to do is find my asymptotes.
So we have x squared plus 2x minus 3 equals 0. Take out an x, so x.
Can't do that.
Oh, minus
Times
3.
negative.
Huh?
Minus 3.
Can't we move the 3 over first and then take
Just
out
factor it.
Just
Or
factor.
just factor?
Man, I hate the stupid games.
Yeah.
Anything in this form, we factor first. What does this factor into?
3 and negative 1.
X plus 3, x minus 1. So, x equals negative 3, x equals 1. Those are my two vertical asymptotes. All right, what about horizontal asymptotes?
Put your on bottom, y equals 0.
Yep. Now, I have to find intercepts. So, think back to when we had standard form linear equations and you needed to find the intercepts. How did you find the x-intercept? Set y equal to 0. So to find the x-intercept of a function like this, we set y equal to 0, and we have that as the function. Now, what happens in this situation?
You can't go to 0.
What happens when I multiply the bottom by 0?
It gets away.
It goes away. So I end up with 0 is equal to x plus 2.
What? Wait, what?
Because you multiply the bottom to get rid of the denominator.
So with an x-intercept, all that's going to matter is the top of a rational function. Okay, the bottom is going to be irrelevant because when we multiply both sides by that, it cancels out because 0 times that is just 0. So when you set this up from here on out for an x-intercept, all you really need to do is say 0 is equal to whatever the numerator of your rational function is. Okay, so that means x is equal to negative 2. My intercept is not x equals negative 2. My intercept is a coordinate point. The coordinate point for the x-intercept would be negative 2, 0.
Nice.
Now, when we wanted to find a y-intercept when we had a linear function, what did we do?
Y equals mx plus b. I don't know.
Set x equal to 0?
Set x equal to 0. So everywhere I see an x in this function, I'm going to put a 0. So I'm going to have g of x, or I'm just going to say y, is equal to 0 plus 2 over 0 plus 0 minus 3. Now I'm just being obnoxious and writing all the zeros. I would normally just ignore them straight up. So that means y equals negative 2/3. So what is my actual intercept then?
Negative 2 over 3.
0, negative 2.
0, negative 2 over 3. Intercepts have to have a 0 in them for the opposite value.
So how can we have an x-intercept if there's a horizontal asymptote?
Yeah.
For real.
Well, the x-intercept is at negative. You can cross horizontal asymptotes. You're not allowed to cross vertical, but you can cross horizontal.
Why does math have rules?
Rules.
Yeah.
But also,
I feel like they make rules to pass other rules.
Yeah. You would also have to graph it and see what it looks like. But I mean, if you put it in your calculator and graphed it, you'll see it.
How do we graph that?
Just plug it into your calculator.
My brain is fried right now.
All right. Questions on that?
Why?
X.
There's like 3 things.
All right, problems. 1, 3, 7, 9, 19, 21, 23, and 25. Now, we only have a few minutes left, so I'm going to give you tomorrow in class to do this and to do, I think are there notes for 2.7? Okay. Well, you'll have time to work on this, and then we might get started on 2.7 after y'all all finish tomorrow, because we have this class on Friday. It's only, I mean, it's a few minutes shorter on Friday, but not like significantly. But that way we could get through 2.7. I would be prepared to have a quiz possibly as early as next Wednesday, but definitely by the end of next week on everything, and then the test shortly thereafter. So